So the area of triangles, when I was a kid, they told me half times base times height. I said, okay, half times base times height. Okay, I'll do half times base times height. No idea why it was half times base times height. And then when I was studying to become a teacher, they actually had us working with the geoboards, they're called, with the rubber bands. Dangerous, the rubber bands. But they had us making these triangles and then saying things like, okay, now how could you make a congruent triangle and rearrange it to make a rectangle? And I was like, okay, let's play around with it. Made a congruent triangle and formed a rectangle. So it's like, oh, that's why it's half times base times height. Because it's half of the size of the rectangle that it would make. And every time they gave me a right triangle, I went, now I understand it. Light dawned on Marblehead. Every time they gave me a right triangle, I went, oh, now I get why it's half times base times height. And then they gave me something that wasn't a right triangle, and I went, uh-oh, now I don't understand it again. So, for ones that aren't right triangles, it's half times base times height. Because if you make a congruent triangle, you can rearrange it. One, two. To make I'm very visually impaired with the trying to coordinate things. Tangram puzzles, don't even get me started, they drive me crazy. So it makes a parallelogram. So this triangle is congruent to triangle D, but it's like rotated maybe and or flipped, but it makes a parallelogram. Now the parallelogram has this as its height and has that as its base. That's why it's base times height. So you'll actually see, because I'm so bad with formulas and my memory stinks so bad, that sometimes if it's been a while, I'll actually redraw it to remind myself of the formula and where it comes from so that I can figure it out. So we have the base times height formula of the parallelogram, except the triangle itself is only half as big. For this one, F, same sort of idea, except it's going to overlap with that one, so I can't really draw too much. But you get the idea, it would make this parallelogram. The parallelogram's height would be this big, and the parallelogram's base would be that big. But the triangle's only half as big, so half base times height. But the thing we also have to keep in mind is base times height. The base and height have to still be perpendicular, just like we had when we were working with parallelograms. Now sometimes the heights are a little bit funkier. Down here, this one, the height has to be the perpendicular distance between the base and the tallest point away from that base. Now the tallest point away from this base is over here, and the base is over here. So your height isn't always going to be the inside measurement. It's not always going to be the inside measurement. They could show it by showing a measurement over here, or they could show it by showing a measurement out here. If you have a right triangle, your base and height are always the legs of the right angle. Oops, those are the fake ones. So here's my right angle. So here's my base and height. And this one, here's my right angle. So here's my base and height. So here, if they show me a measurement on the inside, I got my right angle. So there's my base and my height. So a lot of times people think, okay, it's going to be the measurement on the inside, but not in this case. In this case, it's the measurement outside. But you don't count all the way from here to there. Just this over here and this over here is your height and your base. So your triangle is always going to be a half times base times height. Now, a lot of times people, because of where this formula came from, do base times height divided by 2, and that's perfectly fine. But if you use the half times base times height, you get more flexibility because of the commutative and associative property. I always like to split the even number in half because I don't want to work with decimals or fractions if I can avoid it. Did you have a question about that whole base times height divided by 2?
Yeah, well, not really.
Oh.
So you do the times 2 with even right angles?
I mean times 2, divide by 2.
I mean times
The base times height, and then it's only half
half.
of
So
the
you do that
fractions.
with all triangles, sometimes half of.
So let's go ahead and fill in the notes based on all this stuff. So the area of a triangle equals the product of its base and its height divided by 2. The formula sheet itself might have the formula written in both ways. I'm not actually sure. And sometimes they change the formula sheet. So we have this area equals base times height divided by 2, but we also have it written as half times base times height. Now the base has to be one of its sides, but they might give me numbers or measurements for more than one of the sides, because triangles have 3 sides. So we have to make sure we find a height that gives us a perpendicular distance from the base to its most distant vertex. We always are looking for that perpendicular relationship to figure out which one's the base, which one's the height. And that's another part people mess up sometimes. People often forget to do the dividing by 2 or the times half, so be careful on that. Because of the associative, no, the commutative, that's what I meant. Because of the commutative property, you can multiply the half, the base, and the height in any order. So like I was saying, if my height is an even number, I'm going to take half of that height and then times the base. Don't split both numbers in half, though. That's another common mistake I see. Do not, I repeat, do not split both numbers in half. It's half of one of these times the other one. Or you could find the product of these two and split that in half. But only do a halving of one thing. So in this particular example we have down here, it says find the perimeter and area of the following triangles. So what they did, oh yeah, there is another one there. What they did is made it so that you do need all of these numbers. You do need this 9 centimeter, the 16.6 centimeter. It's an isosceles triangle. So down here is also 16.6 centimeters. And you need the 14 centimeters to answer both of those questions. Sometimes you need them, sometimes part of it is extra information. The perimeter formula is kind of funky on the formula sheet for a triangle. It just says A plus B plus C. It's just saying, hey, don't forget the perimeter, you're adding up the 3 sides. So in this particular triangle, just have to make sure you keep in mind all 3 sides. So 9 plus 16.6 plus another 16.6. And again, because of the commutative and associative property, it's all addition. It can be done in whatever order you like. For whatever reason, this first time I did 9 plus 32.2. But someone else might have done 25.6 plus 16.6. It doesn't matter as long as you remember to get all 3 sides. And, ooh, I messed it up. 33.2. I doubled the 16, but I forgot that the 16 doubled would need to carry. So when I add it up, whether I do it the 9 plus the 16.6 first, or the 16.6 is added together first, I should get 42.2. And what's my label going to be for perimeter of this triangle? Centimeters, not centimeters squared, because remember perimeter is when I could take a string and go along the outside of it and then say how long was that string. So it's just centimeters. Now area. A lot of people are resistant to write down that formula, but if you are, you're probably going to forget to split it in half at some point. So try to get in the habit of writing down that formula. Half times base times height. You have your formula sheet. You can use it to double check things as you're working, even on quizzes and tests. So in this case, half times, who can tell me what the base and the height would be of this triangle?
The base would be 9 centimeters and the height would be 14 centimeters.
Don't always think the base is going to be the one that's horizontal, like it's sitting on the floor. This time the base is over here, because it's the only one for which I know how long of a distance it takes to go to the other extreme. So the base here is 9, And the height here is the 14 centimeters. A lot of times I don't write in my units till the very end. Some people write them as they go. Either way is fine. This is where instead of doing it left to right, I'm going to use my commutative property to, in my mind, move things around. Because who can tell me what half of 14 is? Half of 14 is what, sir? 7. And 7 times 9 is a whole lot easier to figure out, especially if you know your math facts, than 4.5 times 14. Because who can tell me what 7 times 9 is? Yes, sir.
63.
63. And what's my units going to be? What are my units for this problem?
Centimeters squared.
Centimeters squared. Because remember, it's how many squares would fit inside that triangle. Yes, ma'am?
But can you also do like 9 times 14 divided?
Or I could do 9 times 14, but I don't know the 9 times 14 specs. So I'm trying to make my life easier by making my numbers as simple as I can so that I can just use math facts that I know for sure and I'm comfortable with. Because I could have done 4.5 times 14, or I could have done 9 times 14 and then split that in half. I'm going to get there. 126 split in half. But why bother if I can make my numbers smaller and make it into a math fact? So you can. You got the flexibility. Everyone's got this so far? All the work shown? I'm clearing the ink and I'm scrolling it down. Yay! Yes. I lost my scroll bar. Baby, come back to me. I think I added this example in later on because some people were looking always for their height to be inside the triangle. And so this sometimes throws people off. So I added a right triangle in here. Again, the directions are find the perimeter and the area. Behave yourself, computer. So the perimeter and the formula, there we go. So the perimeter again, it's on your formula sheet. It's just saying make sure you add up the 3 sides. Doesn't matter. When we get on a couple of years from now and you're doing the Pythagorean theorem, you're going to find that the A and the B are always the legs of the right triangle, and then the C is always the measurement of cross measurement. But at this point, it doesn't matter. You're just adding 3 sides. So whatever one you like best. And then again, even when you write the 3 sides down, even if you wrote it in one order, you could still add it up in another order because of commutative and associative property. I went wild and crazy. I did 3 plus 9 because I mess up 7 plus 5 all the time. I don't know why. 7 plus 5 and 8 plus 5 mess them up. But you could do whatever order you like. Yes, ma'am?
Oh, this is
So what's the answer including label?
12 yards.
12 yards. All right, area. Again, if you don't write down the formula, you're probably going to mess it up. The area is half times base times height. Who can tell me what we might use as the base and height of this triangle? Yes, ma'am.
The base would be 4 and the height would be 3.
Mhm.
So
Half times 4 times 3. Maybe someone else was looking at the triangle on the side and thought the base was the 3 and the height was the 4. It doesn't matter. As long as they have that perpendicular connection there.
So like you could do like half of 4 times 3, and then you could do like half of 3 times 4.
Mhm.
Okay.
So this is where we have that flexibility. We have that we could find it as half of 12, or we could find it as 4 times 1.5. But I personally like to do splitting that even number in half and multiplying by the other number. But you have that flexibility. You can do it in whatever order as long as you're careful. So what's the area of that triangle down there? Yes, sir.
6 yards.
Is it going to be yards for trying to figure out the area inside of something?
Oh, square yards.
Mm-hmm. 6 square yards. Or yards squared. If you're writing that exponent 2, though, it has to be after the label. Make sense? Sounds good?